So what I'm going to talk a little bit around, because Marco, etc., have spent a lot of time talking about core scheduler, DWC, etc. I'm going to talk about the work that we're doing around scheduler. But I'm going to start off with, I don't know, a little bit of history, right? Because everybody still does refer to TWS, right? Tivoli Workload Scheduler. So IBM acquired Tivoli in 1996, and Workload Scheduler was part of that acquisition, right? So when people say that there's challenges around the UI, etc., right? Well, you are actually using technology that's been around for around 30 years. And one of the interesting things is IBM actually has a whole bunch of products that have been around for probably 30 years or more. WebSphere, MQ as examples. And one of the things we often say about these products is they kind of become a little bit like oxygen, right? No one knows they're there anymore until you start to take them away. And then people realize how critical it is to everything that a given business and sometimes even industries rely on. And it was very interesting that probably middle of last year, had a meeting with the CIO of one of the UK banks. Right? And the statement that he made was along the lines of, online banking gets all of the glory, right? Digital, online banking, open banking APIs, that's where all the focus is. But the business runs on workload automation, right? And that is still true today, regardless of the fact that, the product's origins are 30 years ago. So other things that were happening 30 years ago, right? So according to AI, which did not exist in its form 30 years ago, in 1996, we were experiencing the initial explosion of the internet. We had desktop computers with power, and we had advancements in digital media in gaming. To give you an idea, Windows 95 was the standard operating system. Everybody used 3.5-inch floppy disks, although they were hard. And Netscape Navigator 2 had just been released, which included the first version of JavaScript, which was called JavaScript rather than Mozilla Script to try and leverage the hype of Java, which had only been released about a year beforehand. Right? This is kind of where we're starting. And of course, the other most noticeable thing that happened in 1996 is when I went to university. Now, since then, it is worth pointing out that Workload Scheduler is still used by over 1,000 customers. Right? We still know of at least 1,000 customers, and it's quite a bit north of that, who are using Workload Scheduler in production. It's used by 60% of the world's largest banks, who are managing something like £5.1 trillion worth of assets. It's used by 80% of the world's largest automotives, producing 28.5 million cars a year. It's used by 60% of the world's largest insurers, who are using, they are underwriting about $430 billion worth of insurance premiums, right? So this is an idea of the fact that businesses all over the world in multiple different industries do absolutely rely on Workload Scheduler, and we are fully aware of that. And one of those customers is us, IBM. All right, so all of our quarter close, all of our financial processing, all of our sales runs on Workload Scheduler. All right, so we integrate with SAP, with Salesforce, with Workday. We drive a huge amount of workload doing ETL jobs with IBM DataStage through that. And we also use IBM itself as the way that we test out and build some of the ecosystem around Workload Scheduler, which I'm going to talk a little bit about. So in IBM, we kind of call this client zero, right? Where IBM should be its own client of all of its products, and we should use ourselves as our test beds for what's useful and what's not. To give you an idea, we run in over 170 countries. We do our end of day, end of week, end of month, end of quarter, end of year processing across those 170 countries and jurisdictions. That all completes in 3 days, including Q4 end of year processing. We've been working quite a bit on how we do mean time to detect for job failures and understand the cause of job failures and how we fix those causes and then rerun jobs. We've now got a mean time to detect and ideally repair that's under an hour, but we detect within 5 minutes, and most of the delay on repair is restarting the necessary systems, right? Because some systems take 20, 30 minutes to come back up again. So, as I said, a lot of what we've been focusing on last year, this year, is how we actually extend and bring workload automation forward, not just in terms of what's happening in the product, but how it works with the rest of the ecosystem around it. So we've kind of got the core scheduler, right? And below that, and that then launches jobs, whether they're running on workstations, whether they are interacting and integrating with external sources, right? ETL providers, managed file transfer capabilities. Now, under Workload Scheduler, yes, you can run it in containers, you can run it on Kubernetes and OpenShift. You can schedule workloads that are in things like Kubernetes. I mentioned I also own a product that does high performance computing. You can use Workload Scheduler to schedule jobs on high performance computing platforms. Now, there's 2 reasons people do this. One is they're doing high performance computing and they need to get data in the right place before they run huge large scale analysis. They then need to move those results once it's completed. But the other thing the high performance computing technology is designed to do is provide a utility grid on which you can run compute, including things like batch jobs, with the ability to dynamically steal and borrow compute from other machines and to do slot allocations inside machines to efficiently use infrastructure. So we've got some customers who are doing that to try and reduce their infrastructure spend because they've got large pools of compute that they're running. Now, above that, we then have a huge ecosystem of integrations, right? So if we just take managed file transfer as an example, and you see this a lot inside IBM, we have 4 of them, I think. We've got MQ Managed File Transfer Edition. We've got Aspera for large files at high bandwidth transfer. We recently acquired Web Methods, which comes with its own file transfer capability, and we've got Sterling for B2B, B2C. They each have different use cases. We have integrations with all of them. Now, one of the things that we found is, so we have Automation Hub as a place to get automations. Now, just out of interest, to get integrations, how many people use integrations from Automation Hub? Anyone?
No.
Okay, so this is something that we are hoping to fix. And it's something we identified ourselves. So I said, IBM Client Zero, we do a whole bunch of stuff with Data Stage. One of the first things we asked the teams, so are you using the Automation Hub integration with Data Stage? And they said, well, we tried it, but it didn't do the thing that we needed it to. So we just wrote our own launcher, which is what we hear a lot. So one of the things that we're starting to do, and I'll cover that later, is look at how we make it easier to understand what the integrations do and easier to modify those and feed those changes back to us as the community. But IBM's always had a rich ecosystem of products that get used with workload automation. And we have a lot of new products which could and potentially should be used with workload automation for new workload types. Now, on top of it, there's then how we do management, how we do operations. So a number of questions were asked earlier about things like AI in chat assistants, and potentially maybe easier ways of building workflows. So there are absolutely ways of doing that. We have products that are designed to do that, which can integrate with workload automation. We've got some customers who are doing that. And then above that, we've got how do we do end-to-end integrated operations. And so if a job stream fails, why? Is it the workstation it was scheduled on ran out of disk, had a CPU or a memory problem? Is it we were integrating with an ETL provider and that had a failure? Right? How do we actually do end-to-end operations? How do we do root cause analysis? How do we understand the cause of job failures? And if it is a problem in infrastructure, how do we get the infrastructure problem fixed, know when it's fixed so that we can restart the job? Right? These are all problems that we're kind of been looking at how we solve over the last year and a half or so. So if we look at those in a little bit more detail, right? So we look at agents because, and I reordered this because it came up a couple of times. So, and a lot of this is actually powered by the fact that we now have OQL as a rich query language. Right? So really what AI agents do when you give it a question in natural language is it tries to convert that into a request of the underlying product or products. Right? Now, if the only thing that you've got is a REST API, it tends to be a bit limited in what it can do because each REST API is the implementation of one specific query. Right? When you've got a query language, you've actually got quite a rich set of capabilities that you can use. And what most AI assistants do is they will take your request and they will build a query for you, right? The other thing agents can do is understand that the request that you're making actually needs to be split into 8 or 9 different subtasks. And actually, individual tasks might need to be carried out by getting data from different underlying tools and products. So we can put an agent interface onto workload automation, but we can also put it onto things like IBM Data Stage, if that's the implementation of an ETL job, or onto SAP, or onto Salesforce. So we can have a single interface where you can find out about job status. But that job status might be a query against workload automation and against SAP, because the implementation of the job requires interaction with SAP. So we've been building this out using What's Next Orchestrate, right? IBM's technology for agent and agent orchestration. So both putting an interface on top of workload automation that's using OQL against the APIs, but also against other parts of the ecosystem so that you can ask combined questions. So to give you a very basic idea of what this looks like, and I know it's going to be incredibly small for a few of you, you can ask simple questions like, what's the status of the critical jobs, right? It's going to convert that into OQL. In fact, there's a step twisty there that once it opens, shows you what the query is, right? Now, you don't need to look at the query, but it's kind of there as a way of helping people learn the query language, right? you asked me this question, this is the query you would have used, here's the results that we get back from the tool. And as I said, it can split requests into multiple tasks and farm them out to different tools in order to combine and generate the overall answer. We can do the same thing for individual jobs. So in this case, there's a specific job called payroll. If that actually launches, there we go. So you can look at the status of the payroll job. For the individual job, it then pulls the status for a single query. So it's just building a different query because it's a slightly different question. And you can actually, invoke this as jobs itself. So one of the things that we did as a demo for a customer is whenever we get a failed job, we take the job log and we feed it into an agent and we ask the agent, why did the job fail? Right, so is there anything in the job log that tells us why a failure occurred? Now, in this case, the job log gives us a Java out of memory exception. So most people who've ever worked with Java know that you need to increase the Java heap size in order to fix that, but it actually tells you that that is what you should do. Right? So it's looking at the error message. It's relying on the fact that LLMs have, I think the latest stats are like 95% of the internet is now stored inside LLMs. Right? Huge amounts of knowledge is already in there. So it's just fetching knowledge that it already has from inside the LLM to tell you what to do about a Java error. Now that's a pretty simple case thing. Now, all of this is reliant on a couple of things. So inside Orchestrate, what you do is you either build what's called MCP servers. So an MCP server it's a little bit like a REST API, right? So when you build REST APIs, in an ideal world, you build an open API specification that documents what the APIs do, what the responses are, etc. Right? MCP servers is sort of like the API definition for agents. You add some information about particular tasks and how to achieve those tasks, from which it then infers how to achieve a wider set of tasks. So you can create MCP servers because they're really just API specs for anything. Right? Inside Orchestrate, we've already done this for ServiceNow, SAP, all of the enterprise packaged apps that you can imagine. Lots of products are adding MCP servers for their own products. So in the world of like monitoring and operations, where IBM has Instana, we provide an MCP server. Where Spencer uses Datadog, Datadog provides an MCP server, Dynatrace does, SolarWinds does, etc. And this allows agents to interact with those products and request data and information from them. So we can essentially build single point agent assistance using What's Next Orchestrate that works with Workload Scheduler and everywhere that jobs are scheduled to give you kind of a single interface. Now, that may not be the most useful interface to operators of workload automation. It may be more like the application users. Right? They want to understand the status of their jobs. It may be is actually management executive team that gives them a way of querying the data without having to become a user of each of the underlying products. Now, another way agents can make life more simple is we also have another tool. It's called Concert Workflows, which is a low-code, no-code workflow builder or integration flow builder. Right? So it's got the ability to do event-driven workflows and synchronously driven workflows. It's got a vast library of connectors inside it. Its biggest advantage, though, is the fact that there is a low-code, no-code UI. Right? So you can do drag and drop building of workflows or tasks that you want to be able to implement. You can do that in code and in markup as well. Now, the fact that you can do it in code and markup as well means that we can plug an agent on the top of it and ask that agent to build things. So we can say, well, give me a workflow that interacts with AWS and queries what I've got inside my S3 object store. Right? So you don't need to know exactly how to build the workflow for that. Having told it what you want the workflow to do, it will go and build it for you. And it builds the full flow, which means you can then review and edit it. You can modify as you need. You can, because Gen AI is very good at doing summarization, you can give it a pre-existing workflow and ask it what it does. Right? Tell me what this workflow does. Tell me how it does it. Tell me what parameters or variables are required. And you can take an existing workflow and you can extend it. Right? You can say, well, once the flow actually finishes, I want you to send a Slack notification. Right? Wasn't part of it originally, but we now need to or want to tell people the results into Slack as well as launching it. Now, because we're also very good at interacting with documentation, you can also ask the thing, so now that I've built a workflow, how do I expose it for use elsewhere? It will tell you how to expose the REST API and how to link that into something that would schedule and track the job, like workload automation. So that's just a couple of ways that we can now start to build capabilities around workload scheduler, workload automation from an agent interaction point of view. We've also got the ability to build integrated operations. So one of the things that we do, so we have a product that until last week was called the Cloud Pak for AIOps. It's now called Concert Operate, but it's the same product. And it's our next generation solution to what Netcall was used for, right, as an event management tool. Now, one of the things it does is it builds a topology view of your entire operations environment. So it will connect to things like Datadog or Dynatrace or New Relic or Zabbix or Nagios, which has a view of all of the machines that you've got, what's running on the machines, the health status, the performance of all of your IT infrastructure. Now, what we added to that was the ability to connect to Workload Scheduler and use OQL to understand about jobs, the workstations that jobs are scheduled on, and the integrations that they are launching and what they're integrating with. And we bring that in as a view of topology, right? So we can show here's jobs that are running, here's infrastructure that it's running on. Now, when problems are detected, so we've got a job failure, which an event is raised for, either using EIF or another mechanism, we get an event that says we've got a job failure. At the same time, Dynatrace, Datadog, New Relic, etc., will tell us whether we've got infrastructure failures on underlying machines, in data stores, problems in SAP, etc. So we can correlate them together. We can say we've had a job failure and we had failures on the infrastructure under it at the same time. Now, this helps us understand whether it was actually a problem in the job itself or it's an infrastructure or middleware problem. That means we now know the middleware infrastructure needs to be fixed before we can fix or restart the job. It also allows infrastructure teams to prioritize incidents because they now know what's being impacted. So that is in addition to what we've built inside TWS, right? We've added the ability to expose metrics, logs, traces, but that's about workload scheduler itself, not the jobs that it's running. this extends into the jobs, right? So we build this view of the jobs, the infrastructure. We can go into the network. We can go into storage. We can build a full operational view across tools. From there, when there are incidents, we understand where alerts are occurring. We group them together. We then actually have agent capabilities that investigate the events and underlying data from the machines or the tools that the events are coming from. And we provide full remediation plans, right? So you do, like, maybe the job failed because we ran out of disk on a workstation, right? You need to extend the disk volume on the workstation, or you need to delete the files on the workstation. Only once that is done can you restart the job, because restarting it ahead of that is just going to fail again. And as it does that, in the same way that for an agent assistant where you ask it a question, it tells you what it's doing, right? It tells you, okay, you've given me this query, I'm converting this into OQL. In the case of investigation, it says, okay, we've had a job failure. It was running on this workstation. I'm checking the workstation to see whether there's any events on it. I've discovered I've got an event that says it's run out of disk space. I'm now scanning the disk volume to understand what's using the disk space. And it builds a full investigation plan as it goes. And it goes further than where it finds problems. So if it found a problem on a workstation, it would actually scan the network attached to the workstation and the storage volume under the workstation to see whether there's other problems that might have caused what we see in the workstation. So it iteratively goes through the environment, looking for problems to try and understand where the root cause is. Now, it does that by, today, it pulls data into the platform. So it collects the topology, it collects the alerts and events, it knows about known problems that we've had previously that are stored in things like ServiceNow. What we've got in development relies on the fact that I said a lot of these tools are creating these MCP servers, right? And that allows us to then go and fetch additional data, right? So let's say I've got a workstation, it's running at 100% CPU, right? I use Dynatrace. Dynatrace sent me a machine running at 100% CPU alert. Now, that's not the cause of the problem, right? It might be the reason why the job failed, but it doesn't tell me why the machine is running at 100% CPU. Now, the first thing most operations teams would do is go into Dynatrace, go to the machine, look at the processes running on the machine and say, which one's running at 100% CPU? Which process is it that's causing that? We can do that dynamically, right? Because we've essentially informed our agent, what we want it to do is diagnose the problem, and it knows it's running at 100% CPU. Its next step is to find out what processes are using all the CPU. It will actually iteratively ask for additional data through the MCP server, get that from Dynatrace, surface that up as part of its investigation log, then move on to the next step. Right? Once it's identified the process running at 100% CPU, starts to look at other things about the process to try and understand why. Right? Actually does what an experienced operator does and builds a log as it goes. Right? And this is what it actually looks like. So in this case, this is our summary. There was a job failure. You see it as an infrastructure failure that caused the job failure. And we've actually had 5 or 6 different alerts that have come in from various different tools that we think are in scope of the problem. Now, there's also the ability to request this investigation happens, and you can trigger these automatically. You don't necessarily have to kind of trigger it manually. So we've got this iterative investigation, and if the demo clicks on the button, there we go. So what it does is it starts off with, okay, we got a job failure and we had these alerts on the underlying infrastructure. So I'm going to start with the lowest level alert, right? That's probably the closest point to where the problem started. So it starts by analyzing that piece of infrastructure that had the alert. It then looks for other data on that machine. It looks at the things the machine is dependent on to see whether they've got any problems as well. And it's building this full investigation log as it iterates through the infrastructure, looking to try and understand where the underlying problem is. Now, in this case, it's done something like 15 different bits of investigation, which otherwise operations teams do manually. At the end of it, it builds the summary of like, so this is what we think the problem is. But if you want to see the problems that we found, here's my full investigation log. It will tell you we found a problem here. On this piece of infrastructure, we didn't find any problems. Right? So you can review what it's done automatically, which is a couple of hours worth of investigation automatically, and agree with the recommendation it makes. Or you can go back and say, okay, I still want to go and validate this myself. This then allows us to say, right, so actually we were running at 100% CPU, but we've got a runaway process that's running at 100% CPU. That needs to be killed and restarted. Then we can restart the job. Now, that's kind of like agent interfaces, end-to-end integrated operations. When it comes to integrations with jobs, so again, in kind of like that AI theme, where we can use What's Next Orchestrate as kind of like an interaction layer on top of Workload Scheduler, you can also integrate with it as one part of running a job stream. So one of the things agents is now letting us do is automate certain processes that we couldn't automate before. Right? So some of like the simple things that you can think of is we can automatically summarize documents. Right? So if we had a document that was coming in that we need to scan for certain keywords and classify or tag, or we needed to summarize. There's lots of things that AI can now do that used to be part of a human business process management flow. Right? The more of those things that we can actually automate, the more we can bring under the control of something like Workload Scheduler, because we've removed the human task from it. Now, that doesn't mean there isn't an exception process. AI also has the ability to judge its own results. So you can say, look, we've run AI against it. We've judged our results. Our confidence is not high enough. We'll fall back to the human process for this. But we can now automate far more than we could before, and we can bring that under the control of Workload Scheduler. And what we find is most users are using third-party or first-party software with Scheduler. But as we said earlier, hardly anybody's using it through Automation Hub. Right? So one of the things that we are starting to look at is, even though we've got like a good probably 100 integrations in there, what do we need to do to actually make them far more useful? Right? So they are things that everybody is using. So that best practices for things like how to get data back into job logs about status, all of this is actually done and is reusable. So one of the things that we are about to do, and it's a question as to whether or not it's useful to anybody else, is to start to provide, let's call it for the moment, community source. Right? So stuff that we are doing in terms of integrations on the IBM side. So how we've done our integration between What's Next Orchestrate and Workload Scheduler. We're open sourcing on GitHub. We're doing the same thing for how that integrated operations frame uses OQL to build its topology. We're open sourcing this because I will admit I tried to write an integration about a year ago. And if given that you're not using the Integrations and Automation Hub, you probably aren't aware that it's Java coding. It uses Maven. There's a Maven archetype for scaffolding out your original most of the code. You then build the integration inside it. And when I started work at IBM 25 years ago, I actually worked on IBM's implementation of Java. Right, so my history is in the implementation of Java and Java programming. And I found it quite difficult to build a plugin. Now, part of the reason for that is we're very good at learning by example. And I don't think humans are very good at learning from raw documentation, particularly if there aren't good examples in that. So it's really hard to understand what you do because there isn't examples. Moving to a community source model, and we aren't necessarily going to do this for the existing integrations, but for a set of new ones that we start to build, it's kind of like the more library there is of these available, the easier it is for people to understand how to build them in the first place. But mostly for me, the scenario that I want to avoid is the one that we had inside IBM, which was trying to use the plugin for data stage, saying it doesn't do this thing that I need. So they created their own launcher rather than using the integration. This allows them to see what the integration does, see how it does it, and just tell us what it needs to do, right? It becomes much, much easier to get feedback without having to go through things like an RFP process, which tends to be very, very slow. And for people that have Java programming skills, they can just build the code change and submit it. And so we are currently discussing looking at moving to this model. We're certainly going to start adding some of the stuff that we're building in there. And the last thing I'll do is, so there was a question right at the start about Bob. Does anybody here know what Bob is? Who doesn't work for IBM? Okay, so Bob's like it's a agent assistant for writing code. So what I did in the back of the room earlier was I quickly scaffolded out an integration. So this is a Maven project for building an integration to another source. So it creates a whole bunch of files for you. Now, one of the things that you can ask Bob to do is you can say, summarize for me what this code does. Right? So it's given me a bunch of code. I didn't write it. What the hell does it actually do? Now, what Bob will do is it will ask you for approvals for anything it's going to access from your disk. So if it wants to read a file, it asks for approvals. If it's going to write to a file, it'll ask for approval. You can just say, do it automatically. So this says, okay, so you got demo plugin action.java. It's a custom job executor plugin for IBM Workload Automation. It extends demo plugin job executor. It provides the core action implementation for executing custom jobs within the scheduling system. It basically tells me job execution is under run action. There's some executor commands. There's lifecycle with cancel, cleanup, and disconnect. It also tells me that there's a bunch of commented out code here. It's probably an example. And in fact, that commented out code refers to Spark execution. So it was probably designed to work with Apache Spark. Right? Works that out from a single file. Now, what I can then do is I can say, okay, add a process executor to run action that launches the echo command line. Okay, so it's going to write the integration for me. Right, so it says, I'll add a process executor to the run action method that launches the echo command. Let me modify the code to include proper process execution with error handling. Okay, So it's done that for me. And as we go through it, I'm not sure if you can see it. So it's using Process Builder to launch Echo with the ability to submit the message that you want it to echo. But not only that, it's got this line here that says append job log. Right? So it's also discovered that if you want to track the output, you have to use a method called append job log to put the information into the job log. So it's then streaming the output from the echo command that I'm launching into calls to append job log to create that and send it backwards. Right? So this is absolutely live. It's an agent where I'm asking it to do things. It's actually breaking that down into several tasks, because if I save this, it's then going to actually run all of the tests for me. It's going to understand if there's any test failures. It's then going to tell me what it's going to fix in order to fix the test failures. Right? This is actually genuinely where we're getting to now with agent capabilities. You can interact in natural language. It understands that this isn't just execute a single query. There's a series of tasks that are going to be required in order to get to the outcome. That might require doing different things with different tools. It will execute the sequence, give you the results. And by the way, if I reject this, right, and I say I don't like that code change, it comes back because it's like, okay, you rejected it, but you still wanted that outcome. So this is, okay, I see you aren't happy with it. Let me try a different approach. Let me break the changes down into a small set of discrete changes to see which bits you're happy with. Right? So we are genuinely getting to the point that agents, if you give them the right tools and capability to interact with them under the covers, can start to complete quite complex tasks without you having to know how to do it. I am an IBM Distinguished Engineer. I have written a crap load of code in the past, but I haven't actually written any Java code full time in 10 years. Right? I dabble. I also dabble in Swift, in JavaScript, and Python, a whole bunch of other things. The chances of me remembering exactly how to do this first time is pretty small. Right? Now, go back to that conversation about OQL. OQL gives you a rich query language. Right, if you use it all the time, you'll know how to shape your query. Chances are the vast majority of people that want to get data out of the system won't be writing OQL every day, particularly if they're not the primary users of the product, but they still want to know the status of jobs, etc. It gives them a mechanism to do that. And if that status means I don't just need to query Workload Scheduler, I also need to query SAP or Salesforce as well, it's actually now possible to expose that.
That's really interesting. I've played about with Codex rather than using Bob, just to do some simple stuff. I can't code. I haven't coded in a lot longer than since before you went to university. So, but it's exactly the same principle in the Open API Codex as it is with Bob. So, you've got all of these kind of agents out there. You've got Claude, Codex. Google have just launched theirs as well, haven't they? They've revamped their equivalent.
Yep.
But Bob is specific to IBM. And writing a job executor, I did the same thing. I got Codex to write a job executor for Slack.
Yep.
Because that job type isn't available, just to see if it's possible. And it's written the code. But I've done simpler things with it, like write code that documents my TWS environment. Here's OCLI, which will connect and do the equivalent of Conman SC and all those sorts of things. And all of that output comes back and it formats it and produces a report. So it produces a report, one side on your infrastructure, the other side on your batch. Fairly simple. How long would it take you to write that? Yeah, and it did it in minutes, and it worked. So this is the power behind tools like Bob. But from the Watson Orchestrate point of view, I think there's guardrails that need to be put in terms of, yes, it can do stuff, but you want human interaction in order to do that.
Yeah. In general, I mean, everyone's journey on adopting agents is as an assistant, right? So even in this case, it's generating the code for me, but it's not like it's then compiling it in and pushing it to production, right? It's generating it for me. It's an accelerator.
Absolutely.
So it's not of the building. It doesn't do a build.
Well, it does builds actually, because if I approve the code, it would then build it to make sure it passed the build. It will then run the test to make sure it passed the
I want to
test.
do it on its own. You've got to
You can tell it to, do all of that, but again, you'd still be there at the review stage. Like, are you happy with these changes? It would just be saying, right, here's the changes, we've built them, they pass all the tests. Are you happy?
I've been using Orchestrate quite a bit recently, and to your statement, I built I want to call it job doc, or it ingests the databases of customers that say, job 1, fix this, do this, job 2, fix this, do that. I added a small line into it that just said, what level do you want AI to do? 1, 2, or 3. 1 saying, don't touch anything. I don't want you to, human only. Level 2, make suggestions, put it into the ticket. Level 3, make suggestions and put those suggestions in place. So like when you're going through it, you see a report come through. No one cares about this report. I shouldn't say that. People care about it. It's in the system, but it's not a integral part of your SLA or your critical path. So letting AI try to fix it is great. Where on the opposite side, you got a sales program that sends credit card submissions or whatever. This is super intricate, and if AI makes a mistake, you're getting killed. So you want to interact before it actually fixes it. So yes, the guardrails, you have to build them in yourself.
Yeah.
But it's things that are happening. And then the other thing on that is also repeatable processes. ETL is a common practice at every company. I have got Orchestrate right now. Just here's an ETL process. Please create a new one for dataset X instead of dataset Y. And it goes through and generates it, puts it in place, and has it done in literally 10 or 15 seconds. And it's ready to go and submit. And it works incredibly well.
But I think the business problem that Bob or some of these tools help with, from an IT point of view, is one of the biggest problems that we face within the TWS world is a lack of skilled resources. If you ever had to put a job advert out for a TWS administrator, you get inundated with people that don't know what the hell they're talking about, and kind of wading through it is really difficult. So having the tools for your existing team to make them more productive is actually a better way of going, in my opinion. So that's why we're looking at this kind of technology to help improve the productivity of our team rather than having to recruit more people. I know that there's a lot of people that are scared of this technology, thinking, well, I'm going to be out of a job because of this. Everyone's read in the papers about, Oracle sending an email out at 6 a.m. in the morning, sacking 30,000 people because they're going to replace them all with AI. That's absolute bullshit as far as I'm concerned. That's more a marketing thing rather than the reality of how they're going to run their business. But from a normal people's perspective, this should be seen as greater productivity rather than losing your job.
I was just exactly the same thing. Is this isn't threatening your job? This is enhancing your job. So because I mean, every person here I know has more work than they can finish in 40 hours.
Yes.
And hiring other people just isn't an option, partially because of financial, but mostly because there isn't skilled enough people out there to take the projects off your hands that you're doing, and training them up takes 10, 12 years. So getting AI to help you do that so you can finish your 40-hour week in 40 hours is the ultimate goal.
So you could say to Nige, do a 10.2.7 DWC upgrade, and Nige could send a Slack message to AI and say, deploy 10.2.7 on this particular server. And then it comes back and says, right, it's done. And then Nige claims the credit for it.
Coming back and says it's failed again. So
No, we're being positive, Nige. We're being positive. Right, okay.
Where does,
anything else?
sorry, obviously, Watson Orchestrate is another licensed product.
Yeah.
As is Cloud Pack or that. Bob, where do you get Bob? Is that?
Yep, it's essentially an IDE, yeah. But the underlying technology is exactly what we're using in Orchestrate, in AIOps, etc. Right? It's just where it's being deployed for what purpose. And everything is now building into an ecosystem, right? So we expose agents through the A2A protocol, which is agent to agent, and we expose how agents access data and achieve tasks through MCP servers. So everything starts to build on top of each other. Now, the one crucial bit in the middle is how you understand the relationships, right? So it is the fact that I need to know that if I'm running a job and that's doing something in SAP, there is a correlator, right? What's the particular task in SAP? Well, I launched it, I got the number back. I know that this is the thing that I need to pass from one to the other. So how do I build that view of the relationships between components? It's what observability tools do. They say you've got these machines, this database runs on this machine, this Java process runs on this machine. They're implicitly building the relationships. But as we try and do that across tools, is how do you get that relationship? And that's what AIOps does in the operations space. We connect to your observability tool. We connect to workload scheduler, which knows about jobs and workstations. We map them together. Now we have context that we can pass around.
And the assistant, in terms of IWS, that's available when, or the MCP server, or they're there now, it's all there.
Yeah, so
what's the,
so
I
what
guess it's
we
like, what's the next step?
Yeah, so what we've done for Orchestrate is we've created an Orchestrate agent that hopefully next week we will put as open source onto the Workload Automation GitHub repository, and it gets published in the What's Next Orchestrate category. So it's just there for use. Okay. It's open source, so you can see how we built it, because you can create your own in Orchestrate if it didn't do what you wanted it to. There's something you wanted to change, you can just change it and use your own copy, or you can push that back. We'll integrate it and release a new version of the catalog.
Okay.
Great. Good.
Okay,
Big money.
thanks very much.